going to be going over a few examples where we look at how arrays in C++ are related to pointers. So in this particular program here, I am going to be creating a character array, copying stuff into it, and then sending it to this particular function down here, the altering one. Then I'm going to be doing a similar one with pointers down here. So if we look at this, when I first create it and copy everything in, it adds in our null character at the end, and we have garbage characters at the end. We don't know what that is. Then when we actually alter it, we pass in the array this way. You have to put in at least all but one dimension. I put in the first dimension here, but technically I could have left this blank. Now when I'm actually placing things into the array, I use these dereferences, which you're used to, which have the brackets. And technically this is just dereferencing. This basically says, go one spot in to memory and alter that particular character. It is exactly the same as a pointer dereference. So I've altered this particular one to be A. Now technically what I could do is I could actually take this memory location, add 2 to it, and dereference that spot, and it's acting exactly the same way that I did with the bracket notation. So if I look after I run this one, it's going to go 2 spots in, so starting here, 1, 2, and alter this spot. And that gets altered to be a B. So these two notations are actually the same. Arrays are secretly just pointers. That's one of the reasons that we start at 0 when we're declaring the first character. It adds 0 to that spot and dereferences it. Now we can actually do the same thing with pointers, it turns out. So if I go into this particular function, which is a character pointer, and I pass that in down here, I can use the same bracket notation with a pointer that I just did with an array. So if I look at this 3 spot, that'll go from the 0 spot, it goes over 1, 2, 3, and dereferences it. And I'm going to put a character C into it. So that puts it there. Same thing here as we did up here. You can just add directly to a memory address and dereference it, and alter that as well. There we go. So the pointers and arrays are basically the same thing. The only difference is that arrays, it gives you a set of memory all in a row, whereas a pointer only gives you one spot in memory that you can alter. However, they are treated the same way as far as dereferencing. Now when we're looking at two-dimensional arrays, you can do that thing that I mentioned where you can leave the first dimension empty, but you do have to fill in any other dimension. So if I have 3, 4, 5 dimensional arrays, you have to fill in the exact number of all the rest of these. It uses that for figuring out how to jump by memory allocation. So if I'm looking at this, I create this grid array, I set the 4 spots here, so 0, 1, 2, and 3, using our typical two-dimensional arrays. I can pass it in down here, and this is technically a pointer to this grid. And so if I'm altering things in the array, I'm altering the original grid. So if I say I'm going to alter the 0, 1 spot, and I'm going to alter it to be this value here, it is a direct reference to it, and it does alter the original. This is not a copy. So arrays are basically treated like passing by pointer. One other thing I wanted to mention real quick is this constant keyword. That's what used to be final in Java. It makes it so you cannot alter this variable. However, the constant keyword has a bunch more uses, and I would refer you to the Geeks for Geeks website. And where it gets really tricky is what happens if you have a constant pointer. You can actually put the constant keyword in a couple of different spots. You can put it on the variable, and you can put it on the pointer. It gets really tricky once you start getting into all the details of that. You can also put it on functions. So I recommend you go take a look at that and walk through all the different cases. The constant keyword can be used in a bunch of different places. Final thing I wanted to look at is double pointers. Isn't that exciting? The double pointer is just 2 stars, and it can point to single pointer arrays or single pointers themselves. So what I'm doing here is this is basically being treated like a two-dimensional array. So I create an array on the heap because I use the new keyword and point to those 2 things. I'm actually going to do something having to do with the stack and the heap here, and this will be very important when you get to something like student list. So if I go down here, I'm going to pass my pointer in, my double pointer. The first of these two C strings I'm going to create is going to be on the heap, so I'm going to use the new keyword. So notice it puts it over here. That's important because this will continue to exist once I leave this set character function. So I copy things into it, that's fine. Then I'm going to create this second C string here, which is going to create memory on the stack. So the memory on the stack, when I do it this way, dies as soon as I leave here. It won't exist anymore. So if I copy things into second, I can then set my double pointer, the two spots in it, to be these two character arrays. And you can think of them as single character pointers. So it assigns each of those. Now, once I leave this though, even though pointer 1 is pointing to second C string, as soon as I take a step, that thing that was on the stack is gone. Pointer is still pointing to it, and it's not going to throw an error until I try to access this. I love the little poop emoji. That makes me laugh a lot. So as soon as I print out this, it'll print out first. As soon as I try to print this out, it'll throw a segmentation fault because this thing that it was pointing to is now gone. It was deleted once we hit this close brace right here. So things on the stack only exist that long. So if you have anything that needs to exist beyond that particular function, you need to make sure you put it on the heap. That also means that later on, you also need to delete it. So if for some reason I need to delete first C string, I actually have to call the delete command on it to get rid of it. Hopefully that gives you some more insight into arrays, pointers, and the stack and the heap.